Welcome to Mrs. Merkel's Trig class. I hope you had a nice weekend. Let's get started with the prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri, et Filii, et Spiritus Sancti. Amen. Okay, let's talk radian measures. Some of you have seen radians in physics, and that will help. Some of you haven't. That's okay. We're going to take a look at what radian measure means. Okay, so let's take a look here. They give us a circle, and our circle has a circumference, which is equal to c, which goes all the way around the outside of the circle. It has a radius r and a diameter of d. Okay, so let's take a look at the definition of a radian. A radian is the measure of the central angle theta whose arc length is the same as the radius of the circle. That's the definition that we are given of a radian. Okay, what does that mean in terms of symbols? Well, if we've got theta, and theta is in radians, theta is equal to the arc length divided by the radius. That's basically what this said here. Okay, so what does that mean for us? What it means is, let's talk about this here. Let's say we have a central angle that goes one full revolution 360 degrees around the circle. A central angle that goes around corresponds directly to the circumference. Okay, and if you remember, circumference is equal to 2 pi r. So what we can use is we can use this information that a central angle that goes one full revolution, that's 360 degrees, corresponds directly to 2 pi r. We can use that to say that there are 2 pi radians in 360 degrees. That's where that comes from. There's actually a proof on it. It's in the book if you want to look at it. But what we need to know for today is that there are 2 pi radians in 360 degrees. So what if I told you I only went halfway around the circle, 180 degrees? How many radians are there in 180 degrees? You divide this side by 2 and you divide this side by 2, you get that there are pi radians in 180 degrees. Okay, how about how many radians are there in 90 degrees? Divide again by 2. There are pi over 2 radians in 90 degrees. So what we're going to do is we're going to use this information here to set up a proportion so that we can solve problems converting between degrees and radians. So we'll put this off to the side here and we'll show you how to set up that proportion. So we know that there are pi radians in 180 degrees. Okay, I got that from over here. There's pi radians in 180 degrees. So we set that proportion up. We now know we can find how many radians there are in how many degrees. So let's take a look at what a question or example would be that you'd be answering in your book. The example they're going to say is, how many radians are there in 85 degrees? So what we're going to do is we're just going to use this proportion to find out how many radians there are in 85 degrees. So we're going to say there's pi radians in 180 degrees, and they're saying we don't know how many radians are, so there's going to be x radians in 85 degrees. Okay, so then what we're going to do is we're going to cross multiply to solve for our proportion. So when we cross multiply, we get that there are 80, so we're going to cross multiply, so you're going to get 85 pi is equal to 180x. All I did was cross and multiplied. 85 pi is equal to 180x. Divide both sides by 180. Okay, and you get x is equal to. Now, sometimes they're going to tell you they want the answer in terms of pi, and sometimes they're going to tell you they want a decimal answer. If they want the answer in terms of pi, they actually do want you to simplify this fraction, okay? So these are both divisible by 5. 85 divided by 5 is 17. And 180 divided by 5 is 36. So if they want it in terms of pi, this reduces to 17 pi over 36. So how many radians are there in 85 degrees? There's 17 pi over 36 radians in 85 degrees. Now, sometimes they'll tell you to write it in decimal form. If they tell you to write it in decimal form, what you're going to do is you're just going to put in 17 pi divided by 36, and you will get 1.48 radians, okay? I should have wrote radians up here, okay? So in 85 degrees, there's 17 pi over 36 radians, or in decimal form, you can say there's 1.48 radians in 85 degrees. Let's convert the other direction now, because sometimes they're going to give you radians and they're going to ask you to find degrees. So let's take a look at what that looks like. So let's say our question is, how many degrees are there in pi over 3 radians? Okay, so that's our question. So we set up a proportion like we did in the last one. So let's say we have pi radians and 180 degrees is equal to, so they want to know how many degrees in pi over 3 radians. So, and that's going to be x degrees. So we're going to cross multiply, and we get pi times x is equal to pi over 3 times 180. We're looking for how many degrees. That means we're solving for x. But look at that. We can cancel the pi out because there's a pi on this side and there's a pi on this side. And we get x is equal to 180 divided by 3, which is 60 degrees. So it doesn't matter whether you're converting to degrees to radians or radians to degrees. You just set up a proportion, pi radians and 180 degrees, and then you put the information that you give you either in the top of the top or the numerator or the denominator, depending on whether they give you radians or degrees. If they want you to leave it in terms of pi, that means that you don't, you just leave pi there and you don't. But if they do want you to put it in decimal, then you have to put the pi in, okay? All right, so let's take a look at one last thing here. What they're going to do is, the other thing that we can work with on this is we can say arc length and arc length is S, and there's also the area of a sector. So what that means is, let's say we have a circle here, okay, and we have, that's our radius here, all right, we have an angle, theta, all right. Our arc length is the distance from here to here, that's S, okay, and the area of the sector is going to be area of that shaded region right there, okay? So the arc length is S, that's the length on the outside. The area of the sector is the area of this little pie slice right in there, okay? So let's take a look at the formulas for that. And we have, remember from before over here, we have theta is equal to the arc length over the radius. So let's take a look at this and we'll solve for S. If we cross multiply, you get S is equal to r theta. All I did is I cross multiplied and solved for S. S is equal to r theta. That is an important equation that we're going to use when we're solving these, so we'll box that. Okay. The other equation that we have, it's that A is equal to 1/2 r squared theta, or we can also say, since we know that theta is equal to S over R, yes, we can say that area is equal to 1/2 RS. Okay, so area of the sector is equal to 1/2 r squared theta, or you can write it as 1/2 RS, depending on what you have. So these are our important formulas that we're going to need for solving the questions from going forward. Okay, so we're going to keep this so that we can answer some questions. So I'm on page 611. I'm looking at number 45. And they're going to have us solve for different things. So let's take a look. So page 611, let's take a look at number 45. Number 45, they tell us that r is equal to 4, theta is equal to 1, theta is in radians. They want us to find S, and they want us to find A. All right, so we go back and we look at what formula can help us solve for S and for A. If you look over here, we know that the formula is S is equal to r theta. Okay, so all we have to do is say that S is equal to 4 times 1. So our arc length is S is equal to 4. Okay, so now that would be here. Now let's take a look. How are we going to find the area? Area is equal to r squared theta. Okay, we have that. We have r and we have theta. So let's use that formula. Area is equal to 1/2 r squared theta. Okay, so our area is equal to 1/2 4 squared times theta, which is 1. So our area is equal to 1/2 of 16, which is equal to 8. Okay. Now, the homework is basically playing with these formulas. S is equal to r theta and using the 2 area of a sector formulas. Now, what I would do, if you're really good at this, I would skip to the end of the video and see what the homework is, and I wouldn't look at any more examples, because basically you're plugging, they're going to give you different, they're going to give you A, they'll give you S, they'll give you different things, and they're going to give you 2 out of the 4, and you just have to solve for the other 2. But I'm going to go over a few more examples in case there's one that might give you trouble. So let's take a look. So if you're good at this, feel free to skip to the end of the video. If you want to see a couple more examples, every other one gives you different information. So I'm going to assign the evens, and you guys, and I'm going to do some of the odds right now so you can see them. Let's take a look at 47. 47, they give you r is equal to 4, s is equal to 12, and they want to know what theta is, and they want to know what A is. Okay, so let's take a look at this. See how they give us a different value in this? So we know that S is equal to r theta. So 12 is equal to 4 times theta. We just divide both sides by 4, and you get theta is equal to 3. See what I mean? If you're good at formulas, it shouldn't be too bad. All right, now let's take a look, and we need to find out what A is. So we say that A is equal to 1/2 RS. So A is equal to 1/2 R, which is 4, S, which is 12, and we get that our area is equal to 24. 1/2 of 4 is 2. 2 times 12 is 24. Our area is equal to 24. Okay. Let's take a look at a couple of other examples in case you're having difficulties with this. If you feel like you're good at it, skip right to the end and start trying the homework, and you can always come back if you need to see an example done. Let's take a look at 49. 49, they give us r is equal to 5, a is equal to 15. They want to know what theta is, and they want to know what s is. So we have to look and see, okay, so we have r and a. Well, we can't use this one yet, okay? So what formula can we use over here that has r and a? Either one of these, but I'm going to start with a is equal to 1/2 r squared theta, okay, because I'm finding that one. So a is 15 is equal to 1/2 5 squared theta. 15 is equal to, 5 squared is 25. Half of 25 is 12.5. Divide both sides by 12.5. And you get that theta is equal to 1.2. Okay, so that would be there. Now we still need to find out what s is. So let's use this formula over here. S is equal to r theta. So s is equal to 5. And we just found theta to be 1.2. So you get s is equal to 6. Let's take a look at another example. Let's take a look at 51. 51 gives us s is equal to 10. Theta is equal to 2.5. They want us to know what r is and what a is. So which equation can we use? We have s and theta. Well, let's use this equation here. S is equal to r theta. So that would be 10 is equal to r times 2.5. Divide both sides by 2.5. And you get r is equal to 4. Okay. A, you can use either equation. I happen to choose the simpler one. I said a is equal to 1/2 rs. A is equal to 1/2 r, which is 4, s, which is 10. So area is equal to 20. Okay, let's take a look at another example. Let's just look at 53. R is equal to 2. A is equal to 3. S is equal to, and theta is equal to. Okay, so take a look. They gave us r and a. If we have r and a, what can we find? Look for an equation that has r and a. So we can say that a is equal to 1/2 r squared theta. So 3 is equal to 1/2 r squared, which is 2 squared times theta. So 3 is equal to 2 squared is 4. Half of 2 is 2. So we get theta is equal to 3/2. And it's totally okay to have a fraction. That's not a problem. Okay? So that's theta. Okay? And let's take a look and see what s is. So we have that s is equal to r theta. S is equal to 2 times theta, which is 3/2. So you get s is equal to 3. There's a couple different ways to solve these. I actually solved it differently in my notes than I did just now in the video. Just use whichever equation has the 2 variables and you're only missing 1 variable. Let's take a quick look at 55 in case anyone has a question on this. 55 says a is equal to 8, theta is equal to 4, and they want to know what r equals and what s is equal to. So you have a and theta, so you're going to go over here and you use the first one. So you get a is equal to 1/2 r squared theta. So that would be 8 is equal to 1/2 r squared theta. Theta is equal to 4. 8 is equal to 4 divided by 2 is 2. 2r squared. Divide both sides by 2. You get r squared is equal to 4. Take the square root of both sides and you get r is equal to 2. All right, it's pretty easy once we find out what r is to find out what s is. S is equal to r theta. So s is equal to 2 times theta, which is 4, and s is equal to 8. Okay, so the long-awaited homework is going to be page 610 to 611. We're going to do number 5 to 45, and that is multiples of 5. Very important, multiples of 5. Don't do them all. I just want you to get some practice with them. 5 to 45, multiples of 5. That means 5, 10, 15, 20, 25. You got it? And we're going to do some arc length and area ones. So that would be 46 to 56 even. Okay? If you have any questions, please let me know on Jupiter Ed. Otherwise, I will see you tomorrow. Have a great day.